I'm Kenan, and this is Asset, and we are going to present optimization of temperature control commercial shipping based on mathematical modeling and graph algorithms. So in Thailand, there is a lot of shipping in terms of materials and products. And materials like are mostly fresh foods and or materials or drugs, which can perish easily, so it must be temperature controlled. And so we need to optimize the temperature control feeds by making them less feeds and make them temperature control and make the drug, the quality match for the product for the customers. Okay, and for the temperature control shipping, as known as the cold chain shipping, those are mostly foods and medical products, which are perishable, so different types of refrigeration system, along with the suitable temperature for each type of the food are proposed. Meanwhile, the smart aging of the products is also essential to protect them from the storage and temperature disruptions of the currently phase 8, and most of them are the phase change materials. Okay. So the research question is how to optimize the fleet for temperature control commercial shipping in Thailand, which the average environment temperature is higher than 25 degrees Celsius. So in the literature review, we use the knowledge on two main fields. So it is the mechanics and thermodynamics for optimizing the fleets of the temperature control shipping. And we use the algorithm based on the graph theory. So for the graph algorithm, the mostly used are the basics of the mathematical optimizations. And there are less studies that develop the algorithm for the graph you fulfill the step. So this is the components of the free shipping change. And this is the map and the algorithm they propose, which it will iterate to the cities that will be that we will ship to.
Okay, to optimize the freight for the temperature control shipping, there are factors that is related, such as the temperature or cooling factor, the logistic time factor, the road patency factor, and the capacity available for the vehicle. The graph theory also involved in the modeling tool, since the nodes represents the distribution center and the pickup location, while the edges represent the roads. And to develop the model, we could use the mixed integer linear programming or MILP as one of the methods, as seen in this picture. Okay. And this is the graph optimization, and it could be involved in the algorithm too. We will consider it as the weighted graph, since it is different in the distance speed or the road patency or the transportation cost. And since the algorithms are mostly used as the basis of the optimization, so there are less studies that go on about developing the algorithm of this one. So we are going to fulfill this gap by creating the algorithm based on the graph theory, which meets our objective. Okay, so our objective is to propose a model for calculating the freight based on the mechanics and thermodynamics. And we are going to propose an algorithm based on graph theory to find the optimum freight. Our methodology is divided into two main parts. The first part is the mathematical modeling. So we would have to find the involving variables like energy consumption or the factors or the goods demand or the convergence speed. And then we use the principle of mechanics and thermodynamics. This is the only part that is involved in physics. To find out the exact formula of the road latency or the convergence speed or cooling factor, etc. Then we find the relationship and of each variable and develop the model for the freight. Then the next part is the developing algorithm part. So we have to use the simulation system. It could be like software that have roads connecting the pickup locations and distribution centers. Then from the acquired equation from the mathematical model, we develop an algorithm to optimize the freight based on this equation. And third, we are going to do the trial and error or for the algorithm of the simulation to determine if the algorithm could make the freight the optimum or not. So this is our expected outcome. We want to have the mathematical model for temperature control freight using the principle of physics. And we want to have the algorithm for finding the optimum freight for any mode max. And this is our work plan timeline. And this is our references. Thank you for your listening. Feel free to ask.
5 minutes for
So you have stated that you use the mechanism of thermodynamics to help optimizing the like the paths of like the truck. So I ask you one question: Is this to minimize the distance that you have to travel, or it's others? We need to minimize the energy that costs on the fleet. So if you drive fast, you can use higher temperature, which cost lower, but it will cost on the velocity of the car instead.
You mentioned that you use mechanics and thermodynamics for your model, and I just want to know what is the mechanics equation or thermodynamics equation that you think it should be involved in your project?
I think the obvious ones are heat conduction, convection, and heat radiation. And
Conduction, heat convection, and heat radiation.
Yes.
You include all of heat transport in your model, right?
yes,
Okay. And also, what mechanics that you use?
probably the cost of the car fuel and the velocity. That's correspond to the efficiency, velocity.
Okay. So, and also for the mathematical equations, you talk about a graph theory, and it seems like you talk on the Minkowski space or in the Euclidean space. But if we have some kind of the worldwide transport, you can imagine that our world is not flat; it's on the curved space. And in this case, can this type of transportation fit for your mathematical model or not?
Okay, it is obviously we can, because the graph theory is based on the weights, and the weights can be different and can make no sense at all. It will still work.
Okay.
Any other question? Can you go to slide number 10?
You have you didn't mention about the equation. So can you briefly tell us What are all those?
So these are the constraints of the modeling that we need to create, such as the force here and the distance. So we will have to create the model for optimizing the force.
And also, can you explain more about the graph theory regarding your research?
Okay, graph theory.
Which one? Which page?
Next slide.
This
Okay, so there are some stations of that have the products, and we need to ship them to the other destinations. And we can use the graph theory because there are roads that have the weights and the nodes that are important to have information of transporting. So we can use that to make it by selecting the node for to have the material in first place and use of the algorithm to distribute the materials.
So can I ask a say? Your turn. Suppose I want to go from the top there, this point one to that point. How does your algorithm work? Or how to choose the best route? What are taken into account? What numbers are the edges and the nodes?
It could be like binary search tree if possible.
Sorry, but I was in charge of the algorithm section. So it is this one to this one is like the shortest path algorithm. If there are only one car and we need to transport from this to this, we can use the shortest path algorithm to minimize the distance, and it obviously will minimize the total cost.
Okay, so one more question. Say, what is your part?
I just in the part of the mathematical modeling part.
So what do you use to model
The variables that is involved in physics at the main, because this distance or speed or the one that is involved in the road patency factor, or it could be the heat flow for in the packaging.
All right, thank you. So it's time up. Let's thank the speaker.